Okay, moving on to section 3-4, we are going to now use matrices to solve systems. All right, the methods that I'm going to go through are somewhat similar to here, but again, we're using a different calculator than what the explanations that you see here are. Things will be a little bit different. So a square matrix is a matrix with the same number of rows and columns. And a multiplicative identity matrix is a square matrix in which all entries along the main diagonal are 1, as you see here. Okay. Um, so you can answer 1, 2, 3, 4 based on that. All right. So let's say we wanted to solve this system of matrices, or excuse me, the system of equations using matrices. Well, you could see how you could create a matrix from the information in the equation, from the values in the equation. You got your coefficient matrix. That's the 2, the 3, the 1, and the -4. Then you got your variable matrix, the x and the y equals, and then your constant matrix, the what these two equations are equal to. Okay, so it goes through some steps again here that wouldn't be work for us because of the fact that we have a different calculator. So let me show you how we would do something like this on the calculators that we use. So from the last video, we should be able to remember that in order to create a matrix, we want to go to the templates menu here and go then to the create the own matrix. Or we can choose the size of the matrix if we choose this one here. Okay. So from here, we are going to want to create a 2 by 2 matrix, and that's going to be our coefficient matrix. And then we are also going to create the constant matrix, which is the 2 by 1 matrix that we see here. Okay. Also, I want to name the matrix. I'm just going to use the same names they use. I'm going to use A and B here as the name for these matrices. Okay. So I need a 2 by 2 matrix. Okay, so again, this is how you can solve a system using the calculator. Before I go any further, let me point out here that your matrix equations, or your equations just in general, not the matrix equation, just the equations, they need to be in this form to where you've got them what we would call standard form, 2x plus 3y equals 7. So there may be a situation where you have to rewrite your equations and so that they are in this form. Okay, so continuing here, going to put the values in for this matrix: 2, 3, 1, -4, 2, 3, 1, and -4. Okay, and then I'm going to hit store. Store is right above this variable key here, so I'm going to hit Control Store, and I'm just going to save that in A. Okay, then I'm going to create a 2 by 1 matrix here for the two values that these equations are equal to. That's the 7 and the -2. Plug those in here, and I'm going to store that one as B. All right, from here, what I want to do is I want to multiply the inverse of matrix A by matrix B. What do I mean by inverse? I mean, we want to do A, we want to say A raised to the -1 power times B. Okay, so this will actually, these two numbers that we're going to see here are going to be the solutions for X and Y for this system. Okay, so you see solutions of 2, 1. X is going to be your top value, and Y is your bottom value. And so the solution here is 2, 1. We can check that by just simply taking the 2 that for X, and then plus the 3 times the Y value of 1. And what you'll see is that this is actually equal to 7. So where does this equation come from? Well, if you look at the original equation, it was 2x plus 3y equals 7. So when x is a 2 and y is a 1, that does make this equation equal to a 7. Just actually checking it from here, rather than using the calculator for the other equation, again, we're plugging in a 2 for x and a 1 for y. Okay. And we would see that that is equal to -2. So in fact, the solution here for this one is 2 comma 1. Okay. So that's how you solve a system using the matrix operations on the calculator. Okay. So here you got an example here. Again, these steps are going to be different because of the different calculator. All right. And we can also we can also solve systems of equations where there's 3 equations and 3 variables, quite similarly to the way we just did the two equations with the 2 variables. Okay. The difference would be is that you would create first a 3 by 3 matrix and then a 3 by 1 matrix, plugging in the coefficients of this matrix of x, y, and z of these equations into the first matrix, and then the 16, 92, and 223 into the second matrix, and the 3 by 1 matrix, and then doing the same basic steps. Okay. So I only have 10 minutes recording time, so I'll see how far I can get on showing you this. But I'm going to just go to the templates menu here, choose I want a 3 by 3 because I have 3 equations, 3 variables. And now I can just plug in. I got 1, 1, 1 is my coefficients in that first equation, 1, 1, 1. Okay, looking at coefficients in the second equation, 4, 6, 10. So second one is 4, 6, and 10. And that third equation has variable coefficients of 11, 15, and 20. 11, 15, and 20. And so again, I'm going to store that as A. I could use any letter I chose here, but I'm just going to stick with the A. So that's the coefficient matrix there. Then I need a 3 by 1 matrix to input the 3 numbers that these equations are equal to, 16, 92, and 223. 16, 92, and 223. Let me just check on those at a 92, 223. Okay. So that one will want to be stored as B. So let's escape that. That's not what I want. I want to hit Control and then Variable and then B, and that will store it in there. Once again, what do I want to do? I want to do the inverse of A times matrix B. So in other words, I want to do A raised to the -1 power. That is going to give me the inverse matrix for A, and then we multiply that by matrix B, and we get a solution of 8, 5, and 3, and that's in order of X, Y, and Z. X is 8, Y is a 5, and Z is a 3. Okay. And so you have quite a few solutions there. Quite a few questions there about this system of equations. It is representing a real world problem. See if you can't make sense of that and answer these questions based on what we've seen there. And then do the lesson practice. So the assignment I'm going to give on this one is questions 9 through 15 and 19 through 23. Thank you very much. Have a good day.